Related to speed is this thing called velocity. Velocity has the definition of how fast your position is changing. And so let me talk about the difference between speed and velocity. And the best way I've discovered or come up with to describe this is think about driving. Okay? You're driving in your car. You have this instrument in your car called a speedometer, or as some people like to say, a speedometer. When you look at that instrument, it gives you a number, 60 miles per hour, right? 100 kilometers per hour. It's a number. That instrument has no idea if you're headed north or south, up a hill, down a hill. It has no idea. It's just giving you a number. That number is your speed. Now, if we add in direction, say you're going 60 miles per hour on the freeway headed south, or for you, Tony, 100 kilometers per hour headed east, okay? When we add in that direction, we now have a velocity. So velocity is your speed and a direction. So
Professor, that's
when
really
we
interesting
have,
because in English
yeah,
we
go
call
ahead.
it speed limit. In Spanish we call it límite de velocidad. So we're assuming that there's a direction in which the car is moving. That's interesting.
Right. Yeah, from a physicist standpoint. No. All right. So speed is a physical quantity, right? 60 miles per hour, 100 kilometers per hour. It's a number. Okay. So any physical quantity, kilograms, pounds, whatever. When you have just the number, it's called a scalar. Scalar. But when you add in the direction information, it's called a vector. Okay? And since speed is only a number, it is a scalar. And because velocity adds in the direction information, it is a vector. And that's as far as I'm going to go with it. You okay with that, Joe? All right. We do need to talk about velocity when objects are and how they're moving relative to each other. I'm an old guy. I remember watching movies in the 80s, and there was this really cool movie called Top Gun. And in that movie, there are two airplanes flying towards each other. And one of the characters in the movie says, we're closing at 800 knots, meaning that the distance between the two airplanes was closing at a rate of 800 nautical miles per hour, which is pretty fast. And so what that character was saying was that they were giving us the speed, because remember, they didn't give us a direction, they just gave us a number. They gave us the relative speed. So similarly, if I've got two cars, we got our Lamborghini on the right, and we got our Volkswagen Beetle on the left here. Okay. When you have two objects traveling in the same direction, in this case, I've got both cars going to the right. The relative speed is going to be the difference between their individual speeds. In equation form, I've shown it to you at the bottom. So in other words, you're on the freeway in your Lamborghini, zipping along at 100, let's crank it up. Let's do 200 kilometers per hour. And then we got the Volkswagen Bug zipping along at 80 kilometers per hour. The relative speed between the two is just the Lamborghini, the 200 minus the 80 of the Bug, 120 kilometers per hour. Now that's if they're going in the same direction. Now, if they're going in the opposite direction, back to my Top Gun airplane example, they're flying towards each other. Okay? They're going in opposite direction. Guess what? We add the two speeds. Let's put some numbers to it. This is example 9.2 out of your text. Two cars zipping down the road in the same direction. Car one's doing 55 miles per hour. Car two's doing 45 miles per hour. What's their relative velocity? Well, as I said, they're going in the same direction. So I got to take the difference of the two velocities. So that's the math. But let's think about physically what's going on here. If you're in the Bug doing 45 miles an hour and the Lamborghini's doing 55, from your perspective, already going 45 miles per hour, you only see that the Lamborghini is doing 10 miles per hour faster than you because you're already moving at 45. So it's the difference is the relative speed.